Today we're going to have a look at building a little baby Class AB mono amplifier. To do this we're going to need an LM386 Op Amp Chip. It's actually that little 8-pin chip that's in there. You can buy these little Op Amp chips all over the place, eBay, Amazon, more or less anywhere that sells electronics should have these chips in stock. I got mine from Maplin's in the UK, only cost me 99p, so it's extremely cheap. It'll operate at voltages anywhere from 3.3 to 12 volts or 18 volts, I think, or I have a 4 or 5 or 18 volts for one of the other variants of the chip. So you could use an LM386 for many different things you know that you might want to build where an amplifier might be useful, such as portable speakers, a little baby boombox you can plug an MP3 player into, Bluetooth speakers. They're just a few uses that I could think of. You could even couple it with a solar panel, so it can be powered by a solar panel or powered by batteries that are charged from a solar panel, anything like that. But I'll go into that in another video, I think. So I've had some time today to mess about with this circuit and try and improve the sound quality which comes from this tiny little 8-pin chip, and I've managed to get some pretty good results actually. I'll let you listen to exactly what the LM386 sounded like when I followed the circuit diagrams in the data sheet, and I'm going to do 2 circuits from that data sheet, and I'll show you that they only take a few seconds to build, but because of their simplicity they don't sound very good at all. So there's 2 circuits I'm going to do. The typical application, which is figure 10 in the data sheet, which bare minimum of components to get it to work, and then the second one I'll look at is with the gain to 200, which is figure 12 in the data sheet. I'll demonstrate building the first circuit for you now to show you just how easy it is to build. So if you bear with me, I'll pull this circuit apart and we'll start from scratch and we'll build the boggo standard LM386 circuit that it says in the data sheet. For the first circuit you'll need an LM386 chip, 2 10k resistors. Those are for our input leveling for left and right. You could just connect just the left or just the right channel because it's a mono amplifier. 2 more 10k resistors, 250 microfarad capacitor and a 0.05 microfarad capacitor. I'll be using a 330 microfarad capacitor and a 0.1 microfarad capacitor because I've not got any 250s or 0.05s, but hopefully 330 and 0.1 will be close enough. The only thing that's not on the circuit diagram that I'm following is these 2 10k resistors and a 10k potentiometer for the volume control that I'm going to add in. To complete the second circuit you'll just need an extra 10 microfarad capacitor. I'll put links to the data sheet for the LM386 in the description, and also a link to my circuit diagram in the description as well. Actually, I tell a lie, the 10k variable resistor is on the circuit diagram. However, these 2 10k resistors aren't. So I'll go through what all the pins of the LM386 do right now. So we've got pin 1, the one with a little spot next to it. That's the gain pin. Pin 2 next to it is the input negative. Pin 3 is the input positive. Pin 4 is ground. Pin 5 is your output, so voltage out. Pin 6 is voltage source, so your 12 volts, 3 volts, 5 volts, whatever in. Number 7 is a bypass pin, and number 8 is also a gain pin. So we've got a 10k potentiometer, and I'm going to connect that to the 2 10k resistors. If I pick the right wire, we'll connect it to the 2 10k resistors. Then we're going to connect the middle of the potentiometer to pin 3, which is the input, and the last wire is going to ground. I'll keep all my grounds over this side of the breadboard. Okay, now pin number 4 also wants to go to ground, so we will connect that to ground, and so does pin 2. So we'll connect pin 2 to ground. pin 4 to ground. Pin 5, there is a 0.05 microfarad capacitor to ground. However, like I said earlier, I've only got a 0.1, so it will have to do. I'll just have to find that, bear with me. So the positive leg, get down please Ziggy, and bugger off. So the positive leg of the capacitor is going to go from pin 5 to a ground. So we will connect the ground up. This breadboard is ever so tiny and really fiddly. Then we're going to need a 250, but like I said, I'll use a 330, and the positive of that wants to go from pin 5, and the negative is going to go to the speaker. It's going to go to the speaker positive. So we'll just bridge those two down to the bottom half of the breadboard, and then I've got somewhere to connect my speaker on the front there. And then we simply need to connect up our positive, negative and our speaker. So I'll do the speaker first. Speaker negative goes to ground, and the speaker positive goes to the negative leg of the 250 or 330 microfarad capacitor. I'll just connect the ground rail from the bottom half to the top half of the breadboard. And then we'll connect our 3.5mm headphone jack. I actually got that from a CD drive, a really old CD-ROM drive. So we'll connect the left and right to that, to the two 10K resistors. I often find that using a pair of pliers is easier. Okay, then we're going to connect the ground of that to the ground rail there. And then it's simply just 12 volts in then. I'll take my ground and connect that over to the ground rail. And then the positive wants to go to pin 6 of the LM386. I'll show you what it sounds like on 12 volts first, and then we'll change to 5 volts and 3.3 volts. So pin 6 is there. So we'll connect a 3.5mm stereo headphone jack to our input, and then I'll connect that to a music player. Then we'll simply turn the power supply on. So as you can see, the sound quality is very, very poor. It doesn't really seem to matter whether you turn it up or down, or turn the volume down on the source. That's full volume on the source, and then all the way down. So as you can see, it's fairly rubbish. So let's try the other circuit now. So for the second circuit, all you have to do is bridge pins 1 and 8 of the LM386 with a 10 microfarad capacitor, with the positive leg on pin 1, I do believe. If it doesn't sound too good, we'll change it, see what it sounds like the opposite way around. But I can more or less guarantee what it's going to sound like. It will sound exactly the same as it did before, more or less, but louder. Okay. Turn the power supply back on. All these components that are earthed, one of them might just have a dodgy earth, I don't 100% know, but we'll see. Let's just try again. So because I didn't check what I'd done properly against the circuit diagram, I missed out a rather important resistor. And to be honest, I think I've just popped this LM386 chip. So I'm just going to go buy another one quickly and we'll carry on. So let's carry on building up the rest of my circuit. So where my circuit differs is when we come from the left and right input here, we go into the two resistors as before. Now I've moved these wires over, and the reason for that is there is a capacitor going to go in there. It is a 22 microfarad capacitor. This capacitor is optional, but I will show you what it sounds like with it in, and then I'll take it out and you can see what it sounds like without it in. So positive leg in parallel with the output of the potentiometer, and the negative in parallel with the input of the potentiometer. I'm just going to take these out for the moment. Okay, so from pin 1 to pin 8 we need, first off, it is a 1K resistor. The circuit diagram says 10, however it is only 1K resistor. So we'll put that in. Then this little coil. I actually took this out of a hi-fi system that I took apart. It's where a lot of these components actually came from. The LM386 I didn't get from the hi-fi. Okay, so now from pin 8, there we go. From pin 8, sorry, I'll say that again. From pin 1, we come out of pin 1 through a 1K resistor into this coil and straight into pin 8. Now for the capacitors, we need a 47 microfarad. So the positive of that comes from pin 8 and goes to ground, and what I'll do is I'll just put all those in the breadboard there, and then I will link this to a ground. And then the 10 microfarad capacitor, same arrangement, positive to pin 8 and negative to ground. Okay, we'll just ground those now so that that part of the circuit is complete. All I did last time, if I remember rightly, was ground it to there, and then I grounded that to the ground rail. Okay, now for the big capacitors, or the big capacitor should I say. This one is a 35 volt 2200 microfarad. Now that is actually going to go between the output pin, voltage out, and our speaker. So the positive pin, that's the negative pin. The positive pin goes from pin 5 to our audio outs. Just like that. Then we need a 100 microfarad from pin 7, the bypass pin, to ground as before. Just like that. And the 330 is going to go again from the voltage source, pin 6, with a 330 microfarad. So we're going to go from there to ground. Okay, and now we're going to remove that resistor, because we don't actually need that resistor. And then obviously removing that resistor has left one of our capacitors not connected up. So we'll put that there. And then I've just noticed I also need another tiny little one because the capacitor legs don't quite reach. So I need another tiny little breadboard wire. And that tiny little breadboard wire is going to bridge from there to there, so that those two capacitors are then connected to earth. Fingers crossed. Already there's no squelching, hissing, anything like that. And before we get too much further, I suppose I had better connect up the voltage in to the headphone jack, well sorry, to the potentiometer. I've added a couple of LEDs there just so I can see what the current draw is without actually looking at the ammeter. I know that when that LED, that white one there, is lit, it's flickering on more than it's off, that the current draw is about 100 milliamps. And that's where this little chip seems to perform best for me in this circuit. But just listen to the sound quality. Turn the power supply on. I'll fast forward it a bit to the bass because it draws more current when there's a bass. As you can see, it sounds so much better. So I said I was going to show you what it sounded like with the capacitor from there to there. So we'll just make sure it's turned all the way down, and as soon as I flick the power supply on, we will get our sound. Flick the power supply back off. I'll pull this capacitor out, and that was with the volume turned all the way down on the potentiometer. So when I turn it back on, the sound will only come on when I turn it back up. So there you go. I mean, you could always put that capacitor in on a switch perhaps, and use it as like a loudness function. Maybe altering the capacitor value would alter the volume level. Okay, and secondly, I went and bought another LM386 N-1 because I thought that I had knackered that one. Obviously wanted to continue filming the video, but I just thought I'd show you. Look, Maplin LM386 N-1, 99p. So I can now, for £2, build a stereo amplifier, or I might just build another device with an amplifier chip in there. I don't know, we'll have to keep that a secret, guys. Anyway, there's your bonus footage for today. So have a go at building one of these circuits for yourself, and just experiment with the capacitor values. Let me know how you got on in the comments, see what you can come up with. Anyway guys, I hope you enjoyed this video. If you did, give it a big thumbs up, hit subscribe, and don't forget to click on the bell for notifications of all my new videos. I'll see you next time.